Imagine you walk outside tonight and the sky isn't a sky anymore. It's architecture. A pale, luminous bridge arcs from one horizon to the other, razor thin at the edges and blindingly bright where it crosses overhead, like someone drew a perfect circle around the world and left the ink glowing. It doesn't move like clouds. It doesn't twinkle like stars. It just hangs there, enormous, silent, impossibly precise, casting a faint banded shadow across oceans and cities. Airplanes carve tiny stitches through its glow. Birds hesitate mid-flight. Somewhere deep in your brain's ancient wiring, a whisper. The ceiling of the world just appeared, and it's made of ice. What if Earth had rings like Saturn, and they arrived not as a myth, but as tonight's weather? What does a ringed Earth actually look like from the ground? Start with this. The rings hug Earth's equator, so what you see depends on your latitude. If you live in equatorial regions, imagine standing near Quito, Singapore, Nairobi. You gaze straight into the ring plane. The structure above you looks like a thin, glowing stripe slicing the heavens, a celestial lane marker that runs perfectly east-west. It's so thin from this vantage that it feels like a cosmic blade, a line of light you could almost pluck like a string. Move north or south toward mid-latitudes, and the geometry tilts. The stripe becomes an arch, then a broad, luminous band stretching across the sky, wider at the center, tapering toward the horizon. In the high latitudes, that band grows even fatter, textured with subtle pearly gradations, like a frozen river suspended overhead. In the day, the rings aren't gone. They're a high, pale veil, washed by sunlight. At noon, they soften into a chalky halo. At dawn and dusk, they ignite. Twilight performs its most expensive magic. The low sun sets the icy particles ablaze, and the band sharpens into stacked seams. Outer dusky lanes, inner radiant lanes, and between them, whisper-thin gaps. Some nights, high-altitude air is still enough that the boundaries look surgical. On other nights, turbulence blurs them, and you get a soft watercolor ribbon. The brightest sections glimmer like frost on glass. The darker lanes hint at where dust and rock crowd together, where shadows multiply and starlight struggles through. Then there's the shadow. Saturn's rings throw a shadow on Saturn. Earth's rings would do the same. Around the equinoxes, when the sun shines roughly along the equatorial plane, the rings cast a dim, belt-like dusk across the planet's equatorial regions, as if someone dialed down the world's brightness by a subtle notch. It won't feel like night, but the light's color temperature changes. Mornings in those latitudes looked slightly cooler, bluer. Midday glare softens. Sunset comes with a faint parallel dusk that doesn't match the sun's angle. Photographers freak out. Architects start talking about ring light, not the gadget, but the literal diffused bounce off a planetary ring that changes how buildings silhouette against the sky. The phenomenon becomes a timing ritual. Parents ask their kids, "Did you see the ring shadow today?" Weather forecasters add a new line to their graphics, ring glow, moderate. At night, the rules rewrite themselves. The rings turn into an astronomical billboard so bright in some seasons that they edge out the Milky Way. But it's not one uniform brightness. The band is subtly zoned, like wood grain. If the rings are icy, and they likely are, they're highly reflective, scattering moonlight and city light back down. That faint silver wash you used to get from the full moon, it's now a broad gradient splashed across half the sky. Stargazing changes forever. Constellations that depended on deep, dark contrast, Orion's belt cutting crisp through blackness, the gauzy sprawl of Andromeda, now compete with a softly glowing arch. New constellations are born, defined relative to the ring band. The falcon below the luminous river, the archer at the ring's edge. Planetariums rewrite their shows. Amateur astronomers grumble and then adapt, designing ring filters for telescopes to notch out that bandwidth of sky glow like noise canceling for light. And there are nights, special ones, when the rings don't just glow, they move. Not like a merry-go-round you can watch spin, but in flickers, in patterns. Plasma in Earth's magnetosphere interacts with the ring particles, and strange temporary spokes can appear, shadowy radial streaks that drift across the bright band. At first, they look like tricks of the eye, like the afterimage from staring at your phone too long. But time-lapse cameras confirm it. The ring sometimes grows faint spokes that slide and dissolve. Social media christens them cosmic scratches. News anchors call them the night's slow heartbeat. For millions, it's the first time the sky feels alive in a way that weather never managed. Silent choreography on a planetary scale. People react the way people always do when the universe gets loud, with wonder, superstition, science, commerce, and humor. Festivals bloom along the subtropical belts where the ring arch looks its widest. Beachfront communities host ring rise gatherings at dusk when the band's contrast pops. Street vendors sell prism cards that claim to decode the ring's hidden colors. They don't, but they're pretty. Drone shows trace the ring's curve with LED swarms. Parents film toddlers reaching up from car seats, fingers stretched at that white arc like they're trying to touch the ceiling of a cathedral. The meme factories go berserk. Ring-shaped donuts, ring-shaped lamps. Put a ring on it wedding ads that time the proposal with the brightest segment overhead. Astronomers remind everyone the rings are not one solid piece, but billions of particles, pebbles to boulders, sugar to snowballs, each orbiting Earth where tidal forces keep them from clumping into a moon. The public nods and then goes right back to calling it the ribbon. But curiosity deepens into practical questions before the first week is out. How bright is it exactly? Bright enough that nocturnal animals adjust. Sea turtle hatchlings, already misled by coastal lighting, now face a sky with a permanent luminous stripe. Conservationists rush to test whether the ring's glow disorients them further. Nocturnal pollinators like moths change their flight timing. Birds that navigate by stars find a new fixed landmark, and some migrate along its axis like an express lane in the sky. Urban planners consider ring-aware lighting codes to compensate for the new sky brightness, and sleep researchers study whether the ring glow, subtle yet steady, drifts human circadian rhythms in equatorial towns. Imagine a city that never quite gets fully dark, only slants from daylight to a soft, silvery dusk, because the ring keeps returning a little light back to you. Night shift workers love it on lonely commutes. Astrophotographers pack up and drive to extreme latitudes to find darker pockets, past the ring's brightest band, the same way they used to chase eclipse paths.
The rings would not stay silent forever. Just as they reshaped culture, climate, and psychology in the present, their existence would shape the very trajectory of humanity's future. Start with space. Our modern dreams of colonizing Mars, building lunar bases, and spreading out across the solar system would all collide with the reality of a massive debris field hugging our equator. Low Earth orbit, once a convenient highway for satellites and stations, becomes a dangerous no-go zone. Humanity would be forced to innovate. Launches would have to angle steeply into polar orbits, dodging the ring plane, or punch through carefully mapped gaps in the debris. Rockets would grow more expensive. Exploration would slow, but not stop. Necessity fuels genius. Engineers might develop new launch systems, electromagnetic railguns firing capsules through narrow gaps in the ring, space elevators stretching from equatorial cities carefully threading between lanes of debris, or nuclear-powered craft that can thrust high and fast enough to leap over danger. The ring, meant to limit us, becomes the very problem that accelerates us toward more advanced technology. For children born centuries into a ringed Earth, the arch would not be a miracle. It would be the default. They would never know a sky without it. Their dreams, their art, their ambitions would all carry its shape. For them, the question wouldn't be, what if Earth had rings like Saturn? It would be, what kind of people do we become when we grow beneath a permanent crown? Maybe that's the truest legacy of a ringed Earth. Not the climate it changes, not the satellites it disrupts, not even the myths it inspires, but the fact that it forces humanity to live every day with proof that the universe is stranger, grander, and more fragile than we ever assumed. A ringed Earth would be a reminder carved into the sky that we live not just on a planet, but on a stage, beneath a crown of ice and stone, where beauty and danger orbit hand in hand. And maybe, just maybe, that reminder would make us better caretakers of the world we stand on.